Watching a machine turn a blank canvas into a surreal masterpiece in seconds feels like pure magic. It gets even stranger when that same machine autonomously types out thousands of lines of complex software code. But behind the curtain, there are no spells being cast. These creations happen because a machine is recognizing and manipulating hidden patterns. To understand how, imagine a massive library. Older artificial intelligence acts like a diligent librarian. Its job is to look at the data we give it and sort it, like identifying whether a photograph contains a cat or a dog. Generative AI acts like an avid reader that has devoured nearly every book, painting, and article inside that massive library. The model analyzes its training data to find the underlying rules of human creation, the grammar, the visual tropes, and the structural foundations. Once it has learned those invisible guidelines, it recombines those rules to assemble an entirely new piece of work from scratch. Moving from simply organizing old records to synthesizing brand new files marks the transition into the generative era of AI. If you had used a chatbot like ChatGPT, you have interacted with a large language model. At its core, this works like a highly advanced version of the autocomplete feature on your smartphone. Take a look at this sentence. Instead of reading whole phrases, the model slices language into tiny data chunks called tokens. Using billions of studied examples, it calculates the mathematical probability of the next token and selects the most likely choice. By stacking those incredibly fast mathematical predictions one after another, the machine generates a coherent essay without ever actually thinking or possessing consciousness. When it comes to creating images, one popular method pits two different artificial intelligences against each other in a competitive game. Think of the first AI as an art forger painting a convincing fake, and the second as a detective trying to spot the forgery. In this diagram, you can see the loop. The forger tries again and again, learning from every rejection, until its work is so sharp that the detective can no longer tell the difference. That continuous competitive cycle pushes both sides to excel, allowing these networks to produce highly realistic images and convincing digital fakes. Today, the engine powering the most popular text-to-image tools works entirely differently. It uses what is called a diffusion model, like a fuzzy TV screen, until the image is destroyed. Then they force the machine to practice reversing the process, cleaning up the static step by step. In this video, the machine starts with pure static, slowly sculpting that chaotic noise into a recognizable landscape. Diffusion models use that training to extract a specific requested image from a field of random pixels. Today, these tools write corporate emails, diagnosing medical scans, drafting legal contracts, and designing architectural blueprints. But this brings us back to our library. If a machine learns by studying millions of copyrighted books and images, does that output belong to the prompter or the original authors? Major organizations, including the New York Times, are suing tech companies in court, alleging their journalism was used without permission. Meanwhile, writers, actors, and illustrators are watching the exact tools trained on their life's labor being used to displace their jobs. The rules governing who owns this data and who gets paid for it remain unresolved, leaving society exposed to economic disruption and a flood of convincing misinformation. Ultimately, underneath the impressive visuals and the code, this technology is built entirely on math and human patterns. Every creation requires a person to set the whole process in motion. While the tools of creation are changing, we are still the ones holding the brush and directing the art.